Hello students. Uh, in this video, I'm trying to explain some of the examples on probability, which are important for your semester 1 math stats paper, MCQ exam. The first question over here is, let A and B be two mutually exclusive events. If probability of A is 1 by 3 and probability of B is 1 by 4, then what is probability of A plus B? Now here the hint is when the two events are mutually exclusive, you have the addition theorem remark saying that probability of A plus B is simply probability of A plus probability of B. And so you have to only add the two probabilities, that is 1 by 3 and 1 by 4. Taking the LCM, it is 7 by 12. So this is how you get the answer. The correct answer is 7 by 12. Next question. It says a committee of 2 is to be formed from a group of 2 teachers and 3 doctors. What is the probability that committee consists of both the teachers? Now you all know probability of any event. The formula is NA upon NS. Now here you have in all 5 people, 2 teachers and 3 doctors, so 5 people and 2 selected from it. So that can be done in 5C 2 ways, and 5C2 comes out to be 10 by using the formula of NCR. This is going to be your denominator. Now in the numerator, you have the number of ways favorable to the event. The event is you want both the teachers. Now 2 teachers from 2 teachers can be selected in 2C 2 ways, which is 1 because NCN is 1. And therefore here the numerator is 1. And so the answer is 1 upon 10. No difficult calculations over here. Only 5C2 is 10 can be calculated by using NCR ka formula. So the correct answer is 1 by 10. Next problem. If probability of A plus B is 5 by 6, probability of A is given as 2 by 3 and probability of B is 1 by 2. Then what is probability of AB? Understand this, that probability of AB is nothing else but probability of A intersection B. Now I'm using the addition theorem here, which says probability of A plus B is equal to P of A plus P of B minus P of A intersection B. This is the statement of addition theorem. Out of the 4 values over here, 4 terms, 3 terms are given to you. Probability of A plus B is given as 5 by 6. So do the substitution here. Probability of A is 2 by 3 and probability of B is 1 by 2 minus P of A intersection B. Now this is 5 by 6 and this answer comes out to be, denominator is 6, 2 2s are 4, 3 plus 3 1s are 3. This cross multiplication will give you 4 plus 3 is 7 and it is subtracted. So minus P of A intersection B. Now I'm shifting this P of A intersection B on this side and 5 by 6 on this side. So I get P of A intersection B, which is nothing else but P of AB, which is equal to 7 by 6 minus 5 by 6, which comes out to be 2 by 6, which is nothing else but 1 by 3. And so the correct answer is 1 by 3. This is the correct answer. Little bit of simplification is required over here. Next problem is about the probability distribution function, PDF. The probability distribution function over here is given to you. X is taking the value 0, 1, and 2, and P of X is taking the value 0.2, 0.3, and K. You are supposed to find the value of K. This is most simplest example over here, provided you know the fact that sum of all the probabilities in a probability distribution function is 1. So the total of 0.2, 0.3, and K needs to be 1. Now, steps can be done like this: 0.2 plus 0.3 plus K is equal to 1. So I have 0.5 plus K is equal to 1, and therefore K is equal to 1 minus 0.5, which is 0.5. This is how you can simplify, but actually speaking, it's an oral example. 0.2 plus 0.3 करा म्हणजे 0.5 येईल आणि त्याला 1 मधनं subtract करा. That will give you the answer of K. So the correct answer is 0.5 over here. And different values can be given over here. The easiest way is add the given values and subtract it from 1. That will give you the answer for K. Next example. It's a word problem. 60% of students in a class attend mathematics class. 50% attend chemistry class, while 30% of them attend both. What is the probability that a randomly chosen student from that class attends at least one of the two classes? Now, when at least one of the two classes wording is there, it clearly indicates it is an example on addition theorem. Because at least one means at least one of the maths or chemistry, means either maths or chemistry or both, which is nothing else but probability of maths union chemistry. M and C are indicating maths and chemistry. So when you have union, it is again application of addition theorem. So the addition theorem gives you this formula: P of M plus P of C minus P of M intersection C. We have already used it in the above example. Now here the probability of maths, that is 60%. It is given in the percentage, but you can consider it as 0.6 because it is probability. 60 upon 100 gives you 0.6. Chemistry, the percentage is 50, so the probability is 0.5. And both means intersection, and that is 30%. That means it is 0.3. So 0.6 plus 0.5 minus 0.3 gives you the answer 0.8. And so the correct answer is 0.8. It is an application of addition theorem. Next problem. 2 cards are drawn from a pack of 52 well-shuffled cards. What is the probability that they are both spades? Note that there are 13 spades in a pack of cards. Now, again, I'm using the definition of probability. P of A is NA upon NS. Here, the denominator, you are having 2 cards to be drawn from 52 cards. So that is going to be in 52C 2 ways. And in the numerator, from 13 spades, the 2 cards should be drawn. So that is 13C2. Now you need to simplify these two things. Let me show you a shortcut of simplification. So I have 13C2, that means 13 factorial upon 2 factorial into 13 minus 2, that is 11 factorial into, now this denominator, I'm going to take its reciprocal and multiply. So 52C2, I have 52 factorial upon 2 factorial into 50 factorial. So I take a reciprocal, so I get 52 factorial in the denominator and 2 factorial and 52 minus 2, that is 50 factorial in the numerator I'll get. Now here Out of this 13 factorial and 11 factorial, 11 factorial will get cancelled. So I get 13 into 12 upon 2 factorial is 2. Here again 52 factorial, matlab 52 into 51 will remain in the denominator. And in the numerator, that 50 factorial will get cancelled and I am left with only 2. And the final answer is 1 upon 17. So this is the correct answer. 1 upon 17 is the correct answer. Next problem, very, very simple example it is. P of A is given to you as 1 by 5 and you are supposed to find P of A dash. Now P of A dash, dash means complementary event. Okay, the simplest formula is it is 1 minus P of A. So you just have to subtract 1 by 5 from 1. 1 minus 1 by 5. Now this simplification LCM is also not required. It is like out of 5, 1 is for P of A. So the remaining are for P of A dash. 5 पैकी 1 गेला तर उरले 4. म्हणून 4 by 5 is the correct answer. Okay, just subtract this value from 1 and that is the correct answer. So 4 by 5 is P of A dash. Next problem is a definition based question. The complementary events are, they are both mutually exclusive and exhaustive. This is the correct answer. One more definition based question is this. Two events are said to be dependent when occurrence or non-occurrence of one affect occurrence of other event. That is the correct answer. Now coming to the question, in a batch of 40 students, 5 are swimmer. A student is selected at random from the batch. What is the probability that he is non-swimmer? Now, very simple definition I'm using here. So in the denominator, I have 40 students and in the numerator, non-swimmers, because I want probability of a non-swimmer. So how many non-swimmers are there? 35 non-swimmers are there. And therefore, the final answer is 7 upon 8. This is the correct answer. Thank you.